Hi guys, I'm not in school today, so I'm gonna just teach you something pretty quickly. You could just write all this in your notebook and then you'll have homework. All right, so we're learning the chain rule today. And the definition of it has the word differentiate in it, and I realized we never used that word. So differentiating in math is just finding the derivative of a function. So when you hear that word, if something's differentiable, it means you can find the derivative. If you're told to differentiate, you're just finding the derivative. So if f and g, two functions, are both differentiable, and f of x is the composite function, f of g of x, then f is differentiable, and f prime, the derivative, is given by this product. F prime of x equals f prime of g of x, which will be the outer function, multiplied by g prime of x, which is the inner function, and you're going to do the derivative of that. It'll definitely make more sense with an example. So example number 1, f of x equals 4x plus 1, well, to the 5th power. So what I mean is, when I say the outer function, is you're going to use the regular power rule, which is bringing the 5 out in front of 4x plus 1, and then that gets raised to the 4th. That's the regular rule we've been doing, where exponent comes out in front and then gets decreased by 1. But you have to then multiply that by the derivative of what's inside. So now I'm doing the derivative of 4x plus 1, which is just 4. And then if it can be simplified, you do. The only way you can simplify this is you can multiply the 5 and the 4. You're not going to have to multiply out the 4x plus 1 to the 4th. And you can just leave it like that. All right, so here's another example. So just start with the outer function, the 5 on the outside. Bring that out in front, just like before. I'm leaving the inside function alone for now, but it's getting raised to the 4th power because you always decrease it by 1. But now you have to multiply by the derivative of the inner function, which is what's in parentheses. So that's going to be 12x to the 3rd plus 12x to the 2nd. All right, now you do have to simplify this a little bit more. We can't really do anything with this part because it's to the 4th power. So if you think about PEMDAS, that would happen first, and then you would multiply. But the 5 that's over here can distribute to those because that whole set of parentheses isn't raised to a power. So I am going to distribute the 5 to the 2nd set of parentheses and get 60x cubed plus 60x squared times 3x to the 4th plus 4x cubed all to the 4th. And you just leave your answer like that. All right, the next one, same thing, but there's just a coefficient in front of my parentheses. So when I multiply the 5 by the 3, I get 15. Leave this alone for now. Decrease that by 1. And then multiply by the derivative of what's inside. So that's going to be 16x plus, x to the 7th plus 10x. And then the 15 that's over here can get multiplied by this because that second set of parentheses is raised to the 1st power. We can't do anything with the second one because it's to the 4th power. So I'm just going to bring the 15 and distribute it. All right, 15 times 16, I don't know what that is. $240. So I'm getting this 240 by multiplying the 15 by the 16. And then the 15 by the 10. And then that whole thing is multiplied by the 2x to the 8th plus 5x squared to the 4th. So the next one does look like you could use the quotient rule, but you don't have to, because you can just rewrite it with a negative exponent. And then you can just do it the regular way. So the 7 comes out in front, the negative 7, 3x squared minus 5. You got to decrease it by 1, so to the negative 8th. But then you have to multiply by the derivative of what's in the parentheses, which is 6x. The negative 7 can multiply by the 6x. So that's negative 42x, parentheses, 3x squared minus 5 to the negative 8th. And then we would bring that to the denominator since it's a negative exponent. All right, those are really the only ones I was going to do with you. And then you can do page 5 for homework. I also attached the answers to the homework that would be due today. The 2 product rule ones here, you can check them. And then the quotient rule ones are here. It's all attached. All right, have a good day.